Alright, so I'm here with another application of three variable systems, alright? So, got a new word problem for us. So in this case, we got this florist, and this florist must make they want to make 5 identical bridesmaid bouquets for a wedding, okay? Now she has a budget of $160 and wants to make 12 flowers for each bouquet. Okay? Now roses are $2.50 each, lilies are $4 each, and irises are $2 each, okay? Now she wants twice as many roses as the other two types of flowers combined, okay? So how many of each type should be in each bouquet, okay? Now, once again, the question actually gave us what the variable should be, okay? The question gave us what the variable should end up being, okay? Well, in this particular case, we want to know how many of each type of flower should be in each bouquet. So, I know what my variables are. X, I'm going to say, is the number of roses in each bouquet. Number of roses in each bouquet. I'm going to say Y is the number of lilies in each bouquet. I'm going to say Z is the number of irises in each bouquet. Okay. So I got my variables. The question told me, and notice it's in each bouquet, because I'm going to have to do something in this particular case since it's each bouquet and not all of them total. Okay. So first things first, we want 12 flowers in each bouquet. Okay. So if I take the number of roses, the number of lilies, and the number of irises, and add them all together, I'm adding them all together, I should get 12 flowers, okay? Now, she has a budget of 160 total. It's 160 total, but that's for all 5 bouquets, okay? That's for all 5 bouquets. That's not per bouquet. So since this particular equation here is only talking about one bouquet, I'm going to have to go ahead and actually take that 160 and divide it. I need to divide that 160 by 5 to get the budget per bouquet. Okay, and that's going to get me $32 per bouquet. Okay, so now I know that we need to spend $32 on each one. Okay, so how are we going to get there? Well, if I take 2.5x, that's going to tell us how much we're spending on roses. And if I do 4y, that's how much we're spending on lilies. And 2z, that's how much we're spending on irises. If I add them all together, it needs to be that budget of $32 per bouquet, okay? Not for all of them, per bouquet. And then finally, she wants twice as many roses as the other two combined, all right? So she wants twice as many roses as the other two combined. So to get the number of roses, I have to take the number of lilies, Y, take the number of irises, Z, combine them, so that's adding, and double it. All right, so I get x is equal to 2 times the quantity of y plus 7. The reason is, for example, let's say she got, 4 lilies and 2 irises. That's 6 total. She would want double that for roses, so 12, okay? So that's the way that this equation kind of comes out, all right? So these are 3 equations, and I'm actually going to clean this one up a little bit. I'm actually clean this one up a little bit and make it x is equal to 2y plus 2z. I've distributed that 2 to make it a little bit nicer, okay? So now I have x is equal to 2y plus 2z, and now I can go ahead and find how many type of each of these flowers are going to be in each bouquet, all right? Now, once again, we could use elimination here. But I'm actually not going to because I already have a variable solved for. If I have a variable solved for, I'm going to use that. So I know x is 2y plus 2z, and what I'm going to do is I'm going to take that. Oh, you better believe I'm going to take that. I'm going to substitute it in for x in each of my other 2 equations, okay? Because what this is going to do is it's going to get us 2 new equations and only 2 variables, which is much, much easier to handle, okay? So when I do that, I'm going to have x, which is now 2y plus 2z. I'm substituting it in right here. So x, 2y plus 2z, plus y plus z is equal to 12, so that gets me a new equation of 3y plus 3z is equal to 12, okay? So I get 3y plus 3z is equal to 12. That's one of my new equations, okay? Now I'm also substituting it in for x right here, okay? I'm also substituting it in for x right here, all right? And now I'm going to go ahead and do that. So I'm going to have, I'll put it right over here, okay? So 2.5x, well, x is 2y plus 2z plus 4y plus 2z is equal to 32. So now I'm going to go ahead and distribute this. So I'm going to get 5y plus 5z plus 4y plus 2z is equal to 32. And that's going to become 9y plus 7z is equal to 32. So now I have two new equations, okay? Now I have two new equations. I have 3y plus 3z is equal to 12, and I have 9y plus 7z is equal to 32. And now I can solve this really either way, any way I want. I can now use elimination. I can now use substitution. It's really up to my preference. So it's really up to my preference. And what I'm going to do is I'm actually going to use elimination here, okay? I'm going to use elimination. I'm going to eliminate the y. So I have a 9y with this equation. I'm going to want this equation to be negative 9y. So let me go ahead and rewrite these on top of one another for a second, just so you can kind of see. So I got 9y plus 7z is equal to 32, and 3y plus 3z is equal to 12, okay? So what I'm going to do is I'm going to actually multiply this equation through by negative 3, because now when I multiply this by negative 3, I'm going to have a negative 9y. So in that case, I have negative 9y minus 9z is equal to negative 36, because now when I add this with my other equation, I'm just rewriting it. Now when I add this with my other equation, I'm going to cancel out the y's. 9y minus 9y is 0. That's gone. 7z minus 9z, negative 2z, okay? And 32 minus 36, negative 4. So now I divide each side by negative 2, and I get z is equal to 2. So z is equal to 2, so that means that there are going to be two irises, okay? Always make sure that we're thinking about what this means. We're going to have two irises, all right? That's all that's going to be in each bouquet, okay? Two irises. And now what I can do is I can take this, z is 2, and substitute it into either of these two equations for z. I'm going to go ahead and substitute it in for this one. I'm going to go ahead and substitute it in for this one. So I'm going to have 3y plus 3z, and z in this case is 2, is equal to 12. So that gets me 3y plus 6 is equal to 12, which is going to get me 3y is equal to 6. Subtract 6 from each side and divide each side by 3, and that gets me y is 2. So now I know that I have two irises and I have two lilies. Now all that's left is to find out how many roses there are, and all I got to do is take each of these and substitute into one of the original three equations and solve for x. So I'm going to go ahead and do that. I'm going to go ahead and do that. So I'm going to go ahead and do that over here. So x was equal to 2y. Well, y, wrong color. Y was 2, okay, plus 2z. Well, guess what? Z was also 2. And x was equal to 2y plus 2z. So this is going to mean x is equal to 4 plus 4. So x is 8. So now we have our final answer. There are going to be 8 roses, 2 lilies, and 2 irises, and that is our final answer. Okay, so that is another 3-variable system application problem. Okay, so make sure we're practicing this. Make sure we're being very organized, probably a little more organized than I was in this case. Okay, but when you have paper, it's a little bit easier to stay organized. But make sure we're staying organized, and make sure we're taking each step very, very carefully, and being very, very careful not to make any little sign mistakes. Okay, so that's 3-variable system applications. All right, so make sure we're practicing that. Next video, we're probably going to be doing maybe some systems of linear inequalities. I don't know. We're going to find out. But stay tuned for another video.